Hey everybody. So in this hopefully quick video, I want to help people understand the distinctions between different types of variables. All right. So although this may feel like a little bit of review, and for some of you it may be, I just want to revisit one distinction between types of variables. First, independent variable versus dependent variable. That's the first distinction I want to visit. The second distinction we'll visit is the distinction between a conceptual variable and an operational variable, or the operational definition of a conceptual variable. Okay, but I will call the operational definition an operational variable just to keep conceptual variable and operational variable distinct. Okay, now before we talk all about all those, I want to revisit what a variable is. All right, and that it may sound like I'm being overly basic or overly simplistic, but you'd be surprised at how many people don't quite understand what a variable is. You know, people will talk about, you know, what's the effect of the weather, right? But they don't understand very often. They don't understand that in order to discover the effect of anything, all right, it has to be a variable, which means the thing that you're wanting to look at the effect of has to vary between, at the very least, presence and absence. All right, because a variable varies. Variable, it's able to vary. Okay, so at the very least, a variable must change. It must differ between, it must have a state of absence and a state of presence at the very least, because then it varies, all right, between absence and presence. Now, most things vary much more widely than that. You know, extroversion varies widely from not extroverted at all to extremely extroverted, and there's a lot of room in between. So there's a lot of variance. There's a lot of varying in between complete absence of extroversion and complete presence. All right, but at the very least, a variable must have at least two states in order to vary: a state of absence and a state of presence. Okay, now that's true of all variables. All right, if you ever have a factor that only has one value, that's not a variable. All right, if all of us could only be one age, which obviously is not true, but if all of us can only be one age would not be a variable. But because all of us have a different age, it's variable. It's able to vary. All right. So most things in life are variable. All right. Almost everything in life is variable. But when we're talking about research, it's especially important to understand what the word variable means and what it literally implies. Okay. Now, when we're talking about independent variables and dependent variables, we're talking about very specific things. And again, you know, I'm sure many of you learned this in your high school science classes, or maybe your introductory college classes, but let's just revisit it right quick. An independent variable is the variable that leads to a change in the dependent variable. So of the variables in the study, it is independent of any other variable. The dependent variable depends, the variance in the dependent variable depends on the variation, depends on the variance of the IV. So when the IV changes, the dV changes. Okay, so the dependent variable depends on the independent variable. The independent variable is independent of other variables in your study. Okay, now as I mentioned earlier, an IV any variable has to have at least two states: present, not present. Okay, present, absent. All right, and so in experimental research, that usually translates into an experimental condition and a control condition. The experimental condition is the presence of something. The control condition is the absence of something. All right, and your dependent measure is usually some measurements: frequency, extent, amount, any number of variables that vary widely. In each of the labs, your job is to identify what's causing the change and what's being changed. All right. So when you identify what's causing the change, you've identified your IV. When you identify what's being changed, you've identified your DV. Okay. So, one mistake that I saw in early labs was trying to identify one of the two states of the IV as the IV. All right, and for whatever reason, a very frequent mistake was to identify the second level of the IV as the DV. That was a common mistake. I'm not really sure what line of thinking led people to that mistake, but it must be a common misunderstanding because several people did it. So an IV has to have, again, at least two states. Okay, a DV will have many, but the different states, the different values that the DV, that the dependent variable assumes, should depend on the IV. All right, so people in your experimental condition should have a different score on average than do people in your control condition. Okay, so that's your IV and your DV. Now, this next piece is a little bit more confusing than IV-DV. All right, IV-DV, those are familiar terms. We've encountered them since high school for many of us. But the next distinction that I'm going to make is going to be a bit more confusing. And so if at any point, if after watching this video you're still not comprehending that distinction, that's okay, that's understandable. Because again, it's not a terribly easy distinction to grasp. All right. And I want you to understand it. Okay, so please, if after watching this video you're still not sure you're grasping it, send me an email, we'll talk about it. Okay. Very often when we talk about IVs and DVs, we're talking at the conceptual level. All right, so I'm just going to give you a couple examples. Let's say that we wanted to know if exposure to pathogens like bacteria, disease-causing germs, disease-causing bacteria, viruses, all right, if exposure to pathogens affects people's comfort with familiarity, or I should actually say discomfort with unfamiliarity. All right, so what do we got there? We've got two conceptual variables: exposure to pathogens, discomfort with unfamiliarity. Again, exposure to pathogens. Again, pathogens are viruses, bacteria, germs. Whether that affects discomfort with unfamiliarity. How much do you like things that are new, that are novel, right? So discomfort with novelty would be another way we could say that. Now, those are our conceptual variables, and we can identify which ones are IV and are DV, which one's having the effect exposure to pathogens. It has to have at least two states: exposure to pathogens, absence of pathogens. All right, so there's our IV. All right, pathogen exposure, and it has two states: presence of a pathogen or pathogens, absence of pathogens. Okay, and we have to identify our DV. What's being changed by the presence versus absence of pathogens? Discomfort with unfamiliarity. That's what's being changed. Now, based on prior research, which if you're ever interested in looking into this research, just holler at me. I can give you some readings. What we know is that when people are exposed to pathogens compared to when they're not, they tend to be uncomfortable with new things. They become very uncomfortable with unfamiliarity. So what's being changed is the comfort with unfamiliarity. What's being changed is the comfort with novelty. All right. And what's doing the changing, what's causing the DV to change, is pathogen exposure. But I'm talking in conceptual terms. I'm giving you the variable. But these variables, my IV of pathogen exposure and my DV of familiarity with novelty, those can be manifested and operationalized in many, like potentially an infinite number of ways. I mean, I'm certain it's not infinite, but a lot of different ways. All right. For instance, I'll just give you a couple of examples of how pathogen exposure has been manipulated in the past. In one study, some participants in the pathogen exposure condition were asked questions around a garbage can in which fart spray had been released. the fart spray releases a noxious smell, indicating the potential presence of germs. It's a cue of the presence of pathogens, the smell. All right. So that's the pathogen exposure condition, or the pathogen presence condition. Other people were asked questions in the presence of the same garbage can in which no fart spray had been released. All right. So they experienced the absence of pathogen cues. All right. So we've got the two levels of our conceptual IV, presence of cues, absence of cues, and the operational definition of that is completing questions around a fart spray, completing questions around without the fart spray. All right, that's the operationalization. So we've got two versions of our IV. We've got the conceptual version, which is pathogen exposure, pathogen cues present versus pathogen cues absent, and the operational version, completing a series of questions around fart spray, completing a series of questions not around fart spray. Okay, so those are the exact same IV, just in different versions, a conceptual version and an operational version. Our DV works the same way. There are many different ways that we could measure comfort with novelty. One way is we could just ask people to complete the openness to new experiences questionnaire, which the openness to new experiences questionnaire is a personality measure. But the average result, the final number that you get after calculating the result on that questionnaire, is a number whereby higher numbers indicate that the person is very comfortable with new experiences. Lower numbers indicate that they're not comfortable with new experiences. And so the operational definition of comfort with novelty, or comfort with unfamiliarity, is the score on the openness to experiences, new experiences questionnaire. All right. Another operational definition of that could be we show people a series of homes. All right. Some of which are have very traditional, classic designs, and other homes that have very new, unusual, kind of eclectic designs. And we could simply ask how interested people are in buying each type of home, and then we would get a number, a number that indicates how interested people are in buying the familiar homes versus the unfamiliar homes. Again, that gives us a number whereby higher numbers on the sorry, my puppy was desperate for my attention. Whereby higher numbers, let's say people suggest that they're far more interested in buying traditional homes than they are untraditional homes. That would suggest, higher numbers on that would suggest that they're not very comfortable with unfamiliarity, whereas lower numbers, meaning that they're far more comfortable buying unfamiliar houses, that would indicate greater comfort with unfamiliarity. So in this sense, the operational definition of discomfort with novelty is willingness to buy traditional versus non-traditional homes. So there's many different operationalizations. The key here is the conceptual variable is comfort with novelty, or discomfort with unfamiliarity. All right. The operational definition is scores on the openness to new experiences survey, or scores on a survey assessing how willing people are to purchase non-traditional versus traditional homes. Okay, so they're the same variable. All right, comfort with novelty. It's just a conceptual version of the variable, comfort with novelty, and an operational version, the scores on the openness to new experiences survey, for example. The key thing here is that the operational definition is, you can think of it as the procedure for generating a number that represents differences in the conceptual variable. So pathogen cues, go back to our IV, right? What's another way to manipulate it? Well, We can manipulate it by having people in the exposure queue sanitize their hands. People in the non-exposure queue do nothing relevant to sanitizing their hands. So again, we've got absence versus presence. Absence, do nothing to sanitize their hands. Presence, they're sanitizing their hands. It cues them to believe that there may be pathogens around. So here we have, all right, an operational definition. We now have two for pathogen exposure. We've got presence versus absence of the fart spray, presence versus absence of sanitizing their hands. All right. Now we can then represent those with a number. All right. 1 for presence of this fart spray, 1 versus 0 absence of the fart spray. Or if we use the other operational definition of sanitizing hands versus not, 1 for sanitizing the hands, 0 for not. Okay. But the operational definition is the procedure. It's what is done to get the number. The number is not the operational definition. It's how we get the number. That's the operational definition. Okay, so the operational definition for discomfort with novelty, all right, is the scores, is completing the survey of willingness to buy traditional versus non-traditional information. All right, so our operational definition, again, is just another version of our conceptual variable. So anytime we do have a research question, okay, our research question is probably going to be steeped or framed in terms of the conceptual variables. Does exposure to pathogen cues affect how comfortable people are with novelty? All right, that research question is in terms of the conceptual variables. We then, in order to actually address that question, have to operationalize those variables. We have to have a procedure for getting a number that represents pathogen exposure versus non-pathogen exposure and high comfort with novelty versus low comfort with novelty. Okay, and the procedure for getting those numbers are our operational definitions. Okay, now I've stuck with that first example of do pathogens, exposure to pathogens affect comfort with novelty? I can give you another example. All right, so let's say our research question is, does social rejection influence people's self-control? Okay, well, how could we do that? Well, we need an operational definition of social rejection. Well, one standard one is having people play a game in which they believe they are playing this game with other people, and the game is a virtual ball throwing task. Okay, well, in the social rejection condition, people are thrown the ball for like the first 6 passes from other players. The other players aren't real, they're programmed. And then after the 6th pass, those in the social rejection condition don't get any more passes. They never get the ball thrown to them again. Whereas in the non-rejection condition, they get the ball thrown to them for the entirety of the ball throwing task. So they always get included. All right. So we've got social rejection where the ball starts, the other players, which again are virtual, stop throwing the ball to them after so many throws. Whereas in the no rejection condition, they always get the ball thrown to them. All right. So that's our operational definition. Social rejection, rejection versus no rejection, that's our conceptual variable. Data, please stop, baby. My puppies are desperate for my attention. I apologize. All right. Whereas my operational definition is getting the ball thrown to them versus not getting the ball thrown to them. Okay. Now, what about my DV of self-control? Well, one way to conceptualize self-control is persistence. Okay. So how long will you persist in doing something that may or may not be very, or that we hopefully designed is not the most enjoyable thing? So we might do something like a geometric figure tracing task, where we give you a figure, and that's a series of shapes and squares and circles that's all put together in one figure. And your job, the participant's job, is to trace over the figure in such a way to never go over the same line twice. Okay? Now, we create the scenario where the figure, it's actually impossible to do it. So we just see how long they persist. How many tries do they keep? How many times do they keep trying? Okay. The more times they try, the more times they persist. And so our DV is the number of times they try. We could also operation in a different way using the same task as the amount of time they try. All right. So the more time they spend trying to complete this task, the more they persist. Okay. And so our operational definition of self-control is either time in which they persisted, or number of tries. Okay. So our operational definition is the way we get a number. All right. The way we represent our conceptual variable in numbers. Okay. So again, with that second example, does social rejection impair self-control, or does it affect self-control? We might expect that those people for whom the ball isn't thrown to them the whole period, they may persist less, either by, again, depending on operational definition. If it's the time taken operational definition, then we might expect that those to whom the ball is not thrown the whole time, they may spend less time trying to complete the figure tracing task. If our operationalization is the number of tries, then the people to whom the ball isn't thrown the whole time, they may try fewer times. All right. Whereas those in the absence condition, where they're not rejected, they're included the whole time, if our operational definition of our DV of self-control is time spent, they should spend more time. Or if our operational definition of self-control is number of tries, they should try more times. Okay. So again, we've got our research question, which is steeped in the conceptual variables. Does social rejection impair self-control? Social rejection, our IV, impairs self-control. What's self-control being affected by? The presence or absence of social rejection. So the IV, what's having an effect is rejection versus no rejection. What's being affected is self-control. Okay, but then we have our operational definitions. Social rejection, the operational definition is having the ball thrown to them the entire time, that's no rejection, or only having the ball thrown to them for the first part of the study, rejection. The operational definition of the self-control variable is, if we do the geometric figure tracing task, time taken to complete the study, or time taken, how long do they persist in terms of time? Do they persist in trying to complete the task? Or how many tries do they attempt? Okay, so there you are. There's two examples of conceptual variables and their operational definitions. Again, every variable has two versions, a conceptual and an operational. All right, we call the operational definition of the conceptual variable. Okay, but if your conceptual variable doesn't have an operational definition, you can't measure it. All right, because you don't have a procedure for doing so. That's what the operational definition is. Okay, so every IV and every DV is going to have two versions, a conceptual version and an operational version. All right, and I hope that I've laid out well enough for you in this video the distinctions between those. And it's important to be able to identify the distinctions. It's important to be able to identify the conceptual and the operational version of each. Okay? All right, guys, that's it for our video today. As always, if you have any questions, please send them my way. If not, have a great week, and I'll see you next time. Bye, everybody.